All right, cool. So turn the lights off, maybe. Yeah, I think it's more talking than whiteboarding for this one. Cool. Today we're talking about callbacks. Do you guys remember doing callbacks? Maybe like a few weeks ago. I think end of week one, beginning of week two, a little bit. Who remembers what a callback was? Yes.
It's a function defined on the spot within another function, or called on the spot.
Yes, potentially yes. So what really makes a function, so the way that people talk about it is this is a callback function. And what that means is this is a function that I pass into another function to execute on my behalf, right? So do you remember during week, I want to say it was like the first day of week two, we had those functions where it was like, oh, here's a number, can you add two to it, right? Or here's two numbers, can you take one and take them to the square root? Like basically, if I give you a function for you to execute on my behalf, that function I'm giving you is called a callback function. I think the most prominent example one was the one where we were calculating the taxes between New York and New Jersey, like the NY biller one, where we gave someone a function and they called it on our behalf, right? So when would, like, in what instances would you think a callback would be most useful? I think I talked a little bit too last week as well.
Lots of them.
Lots of them. Let's be more specific.
Yeah.
When
I think do with math.
when you do math,
Yeah.
in what way?
Like multiplying or adding, to an array or adding to, numbers.
Oh, like here's my array. Here's I want you to do to it. Now do it for me like over and over again.
Right.
Right. That's totally possible.
Or when you have, the New York, New Jersey biller was probably an ideal example. When you have like a bunch of similar things that aren't quite exactly the same, and you want to differentiate between them.
Yes, possibly. Yeah. So basically, if I have a bunch of like different inputs, right, but I'm using the same function for all of them, I can just feed all my inputs at once, have this static function, and it just kind of churns through like different inputs to give me the outputs I want.
Right. Yeah. Like all 50 states, some have sales tax, some have.
Right.
Yeah. So.
Yeah.
Yeah.
The other instance in which most people who learn programming learn callbacks through is this idea of making web calls, right? So I think I used this example before, but if I was to say, hey, can you, I'm logging into Facebook, right? Facebook is going to give me, a list of my friends, and they're going to say, hey, which friends was updated recently? I'll put them up front so David sees them first. Well, the order in which I do that is actually very important, right? Because if I ask Facebook to get me some data and then to do some things with that data, I want to make sure that happens in that order, right? I ask Facebook, Facebook gives me data, then I do things with that data. If it happens out of order, if I say, hey, Facebook, can you get me this data? And then I start doing with it right away, and then only after I start doing that action does Facebook get back with the right data. In that case, my entire chain falls apart, right? And the process is broken, right? And so the reason why this is really common in web calls is because when you're a programmer, you don't actually know how long a web call could take, right? Because a lot of it is out of your hands. It depends on how fast a call gets to the server, to the endpoint. It takes however long for that server to say, oh, this is what they need. And it takes however long for the server to get that back to us, right? So as a developer, you can say, I know it'll take some amount of time, but it's super hard for you to pinpoint exactly when. And so if you say, hey, get me a number, and then I'm going to multiply that number by 10, you kind of need to wait for a number to come back before you execute the multiply by 10 function, right? And so this is probably one of the most common use cases for these callback functions, is when you know for a fact that you need to execute this on something, but only after it has been given back to you, but you don't know how long that will take. So callbacks, especially on the front end, are super common, right? What happens in most cases is there'll be a function, and I will try to get some other pieces of data, and then the person will also pass a function into that function, right? And inside that function, what's going to happen is they're going to try to get the data, and only after the data comes back does it then call the function you gave it. So that way you can be sure that no matter when that function is called, it can only be called after the data has been received back. And so that's one way in the programming world. It's one way that we try to kind of maintain this sense of order, right? The order in which things happen. When you look at traditional functions like the ones you guys have been writing, right, it reads pretty much top down, and it won't execute a line until the previous line has been calculated or rendered or expressed or whatever it is. So it goes in very sequential order. And if one line breaks, nothing after it runs, right? We get an error on line 2, line 3 and onwards never runs. In the real life environment, you probably don't want that to happen in a lot of cases, right? So if I'm getting, my friends list from Facebook and assuming I have a lot of friends, that list could take a while to generate. So I don't want Facebook to just like do nothing while I'm waiting for my however many friends to come back from Facebook. I want Facebook to render everything else too, right? To render my events, other things, to render my events, to render my photos and anything else.
I'm the fellow.
Okay, cool. Yeah, so to render my events, to render my photos, render everything else, I want Facebook to do other stuff for me while I'm waiting for this data to load, right? And because I gave that function a callback, whenever that data does come back, I can just use a callback on it right away to say, hey, while you're doing that, I'm gonna do this other thing, and when you're done, do this too. Does it kind of make sense in how we use callbacks? Like it's just something that like we can give someone else the authority to use a callback function because we know that it has to happen in a certain order and we never want it to execute out of order. So a callback function is a function that another function takes as an argument and calls. So when we look at this code example here, if we just jump down to line 13 really quick, the first function that we call is this overseer function, right? Up top on line 1. And what this function does, it takes in two parameters. It takes in a number and it takes in a function. And it can be any function, right? But the one thing we do know is that whatever this number is, that's going to be the first argument to this operator func. So what does that tell us? It tells us that we can pass whatever function we want in, but this function that we pass in has to be able to take a number as a parameter, right? And so on line 13, the order in which things are happening is I'm saying, hey, overseer, here's a 10 and here's a function. And overseer says, great, I got your number, I got your function. Now I'm going to execute the operator function by passing in a number as the first input. What's the function passing in? It's called add2, and it takes in a number and just adds 2 to it. So if I was to execute this function, overseer is going to get add2, it's going to get 10, it's going to call 10 on add2, and add2 is going to return 10 plus 2, so 12. It's going to return it to overseer, and then overseer is going to return the 12 back to its console log. So that's why at the end of it, we log out 12. Kind of make sense? Right? Pretty straightforward, right? We're literally just executing this operator this function. Same thing down here, right? It's the same idea. We're using overseer again, except this time we're passing in another function called multiply by 2. Notice how when we get over here, it doesn't matter what we called it out here, right? This is the argument and this is the parameter. So the parameter is still going to assume that we're going to give it a function that's going to take in one argument. And then when we execute this, we take the 10, we pass it into here, and then we pass it to multiply by 2. Multiply by 2 runs, we pass in 10, and so on line 10, we return 20. We return that out to line 2 to overseer, and then overseer returns that 20 out to the console log. And that's when we log it out here, we have 20. Okay? Notice out here in lines 13 and 14, when we pass these functions, we don't ever put the parentheses like after it, right? Because the parentheses indicate that we want to invoke it at that time. If I put the open and close parentheses after add2, what that tells JavaScript is, hey, before you even pass it into this function, execute it. And so what that means is, in this case, we're going to be throwing an error. But if there was an open and close parentheses after it, what that tells JavaScript is, I expect this add2 function to return another function that then becomes the argument that gets passed in overseer. Okay, all of that is to say that when we see this add2 and this multiply by 2, remember these are just variables for now. Okay, they're just variables that represent a function. Don't invoke them right away because unless you want to, in this case you definitely don't, right? You want to pass them in as variables like you would a number or a string or a boolean or any other data type for that matter. But once it's being passed in, only then do you actually execute it on certain parameters. Yes? Good? Make sense? Side of the room? Good?
It's just a coincidence that the parameter is for all this. Like it could be.
You can name this anything you want. Yeah. Parameters, remember, you can name parameters whatever you want. The arguments are what goes into it down here, but once it gets into like your little scope, you can name it whatever you want. Okay? So yeah. So if multiply 2, for example, didn't have an argument, then we would be invoking it without passing an argument in out there as well. So today's class is actually I actually really enjoy it because what it does is it does things in like this kind of like for now at least I think so far you guys have done things in like a very kind of very I guess tedious would be the word to use because you're writing a lot of code, right? Like if I said, hey, here's a list of 20 things, can you do it? Can you do something to it for me? What you guys are going to be doing is usually you write like a for loop or a while loop, right? And you iterate over the entire loop, and there's a lot of and that's a very common paradigm in JavaScript is to iterate over a list of things, right? To iterate over an array of things. So what JavaScript has done is going to say is what they've done is they've basically said, all right, I know there's like these like 4 or 5 things that people want to do over a list, and usually whatever they want to do involves engaging every element in that list. So I'm gonna give you some built-in functions that actually lets you do that a lot more easily. So one of the key things to know about these these functions here, right? Array.forEach, filter, sort, map, and reduce, is you theoretically speaking, you actually you could go through your entire career without ever using these functions, and you'd be totally fine. Okay. What these functions do is they make it easier. They give you a more easy, convenient way to do things, especially when you're iterating over a list. Okay, so these functions are ones of convenience. They're not ones of necessity. However, when you start programming more and more, when you read other people's code, most programmers do use these functions, and some iteration of this function exists in almost every language because of how common of a practice it is to say, here's a list of 30 things. I want to do something over this list. Okay? And the reason why we're learning them today is because all these functions take one thing really. They take a callback. Okay? And what a callback does is, in this case, so actually let's just go to for each, and I think we'll see the callback example a lot more clearly, right? So here on line 35, we have this array that has 3 numbers, right? 1, 2, 3. And the way we call the for each function is we say array.forEach. And then what do we pass in here between these parentheses? Or what are we passing in here?
Function.
Right, anonymous function or a function, right? We're passing in a function here. And so this is going to be the pattern that you're going to see for all these array methods, is that all of them take in a function, right? Do you kind of see where this is going? All of them take a function, and on your behalf, they'll just execute that function on every single element in your list for you, right? Up until now, so I'll just repl this really quick, right? Up until now, for example, if I said, hey, I have this array, and it's 1, 2, 3, 4, and I say, hey, can you print out every number for me? The common way for us to do this is say, okay, for var I equals 0, I is less than arr.length, I plus plus, I go down here and I say console.logout arr index of 1, or sorry, index of I. And what this will do is, this will, what? Oh, huh. Okay. And what this will do is this will go through and console log everything out for me, right? But notice how much typing I had to do for something that was actually relatively straightforward, which is just, hey, I have this function, and in this case, this function just says, take in the number and just console log it out for me. And I want you to do this over every single element in my list. Okay, so how for each works is, like I said, the way we call for each is we say, so all arrays had these functions built in. So we say array.forEach. That's the first step. Okay, and actually let's write this variable out here, right? So let's just say I have this function out here that I call console log num. Okay. For now, just let's take it for granted that it takes in a number, and all it does is it actually console logs out that number. So here we just write console.logout num. And all I'm gonna do is I'm gonna pass that function into this for each function now. So now when I run it, it actually does the same exact thing. It still console logs out 1, 2, 3, 4 for me. And the reason why it's doing that is because it's taking in this callback function called console log num over here, and it's just printing out, it's just executing that on every single number in the array on my behalf. So I don't need to worry about having a var I equals 0 or going through the index and iterating over and incrementing the counter like I am down here. Any questions on this before I dive a little bit deeper into what's happening behind the scenes? Yes.
In this case, what would happen if there was a nested array?
That's right. Right? So this is just dumb, right? It's just saying, hey, take the next element you have. Like for every element you have, it could be an array, it could be an object, it could be, you know, a boolean, a string, anything, and just print it out for me. And so the next question I guess I have is like, where does this input come from? Where does this num come from? I know its value is every element in the array, but where do I actually pass in the num into the callback function?
The function for each defines what the value is.
Right.
Yeah, you got right at the beginning where you say array for each. Sorry.
Yeah, so for each, if you think about like what for each is, right, and we can try writing it out ourselves, just to kind of get some better transparency into it, right? But the for each function actually looks remarkably like this for loop we have down here, right? So let me just comment out these things down here, okay? And I'll write, you know, function for each. I hope it's not reserved. Okay, cool. Okay, cool. So here I'm just going to try to write what for each is actually doing behind the scenes. Okay, I'll move this up. So I have my function called for each, right? And it takes in what? As far as I know, it takes in a function, right? That's the only argument that I called it with up here. Right? I just passed it a function, and so it's almost like it knew what to do with it. So once we have that function there, the next step is to say, okay, great. So I have a function, and I know I want to call this on every element in the array. Where is the array right now? For now, let's just assume that like var arr var array is like a global variable, even though I hate using that term. Like assume it's like a global variable, and this for each has access to that global variable. What for each is really doing is it's going to do this for loop for you, right? It's going to say, hey, start as index 0 while it's less than the array.length, and increment the counter, and let's just execute func on every single element. And this is pretty much what for each is doing behind the scenes, right? Is that on your behalf is actually calling the function for you. So now the question is, in this case here, I can see very clearly that I'm passing in array index of I into the func. Out here in the previous example, I actually didn't see that. And so this is kind of like where a lot of the black box-ishness of the array functions are coming in. So each array method actually passes in something just a little bit different into the callback. So in a for each function, you actually can expect, I think, up to 3 arguments. And the best way for us to figure out what those arguments are, so let me delete this really quick. So bring this back here now. So I'm going to call this var1, var2, var2, var3, and then var4. Okay? And what I'm going to do is I'm actually just going to print out what each one of those arguments are. And just to kind of be meticulous about this, I'm going to make my array of length 1, just so we don't get too confused, okay? So when I run this function now, I see 4 things get printed, okay? var1 is what? Or what does it look like var1 is? Right, var1 is the value of the first element in the array. What does var2 look like? The index, right? Which index am I at right now? And in this case, because we're looking at the first element, the index is 0. What's the third element? Yeah, the third element is the array itself. And then what's the fourth? Right, it doesn't. So yeah, so it doesn't take a fourth argument, and in fact, I can do a 5th one too down here, just to see what's going to show up, and it should just keep showing up undefined. Essentially, what this tells us is that for each, right, for every function that you pass into it, it's going to invoke that function, and it's going to pass it 3 things. It's going to pass it in the value of the array, the index of the array, and then the array itself. And that's a given in all these functions, that no matter what you do, for each will always pass only those three things into your function for you. Okay, and it also passes it in that order. So this is like one of like the few times in which memorization matters probably a little bit more, is because it actually passes it only in that order. So if I only want to get the value of the array, I can actually cheat and just get by with saying, hey, you know what? Like I actually just want to get var1 because I only need the value of the array. But if I wanted to know the index of the array, I have to pass in two arguments because I know that no matter what I do, for each is always going to say, hey, the second argument I give you is going to be the index, never the first. Okay, so in terms of kind of like black box, what's going on behind the scenes is for each is it's going to call this function, and for every time it invokes that function, it's going to pass set to the function three things: the value of the array, the index of the array, and then the array itself. Okay, and it's going to call that function over and over again for every element in the array, starting from the left and going all the way through. In fact, that's one of the things about for each that's actually particularly tricky, is that you can't actually stop it, right? Like it will keep going, right? In a for loop, you can say, hey, if index I equals 7, right? Or if index is less than 4 and your list is 10 things long, I want to do something to the first 4, I can stop when that function runs. Here, you actually can't. The array.for each will just go straight through.
What does it look like if you have more than one element in your array?
If I have more than one element in my array,
Yeah.
cool. So let's do it. So let me do this. So I have these 5 things. And let's say I have something called David. So this is running twice, right? And actually, you know what? After
Turn around once for each item.
right, and here I'm just gonna say console.log. I'll write down like end of one loop. Okay, it wasn't very clear, but so for the first element, which is a 1, the value is 1, index is 0. The array is 1, David, and then the other one is garbage variables I'm putting there just to show you guys, right? The second time it runs, it's going to say go to the second element, the value is David, the index is now 1, the array is still the same, and then the other 2 garbage values are the same still. Right, so it'll just keep doing this for however many variables I have in the array. So the good thing is this is a shorthand, right? It makes it really easy for you to iterate over an array. The bad part is you can't customize this nearly as much as you could a for loop, right? In a for loop, you have a very precise control over the index, right? If I want to do something to every other item in a list, how do I do it? Well, actually,
Increment by 2.
yeah, you can increment 2. I think like you can still do it here that way if you want, but you just have a lot less like flexibility, right? Like a lot of it's kind of abstracted away from you, so you don't actually see the nuts and bolts of what's happening behind the scenes. And by the way, it's totally so easy for us to do this by hand if we want to, right? We could write a for loop that prints out the index, prints out the element's value, and prints out the array very easily. But this is just like a faster way for us to do it, okay? So array.for each is going to take in a function, and it's going to execute that function for every element in the array, and it's going to pass into that function 3 things. It's going to pass in the value, the index, and the array itself. Any questions? And this is just to show you that for a function, because we don't explicitly return anything from the for each, what does it return? It returns back undefined. Okay, any question on for each so far?
Wait, why is foo undefined? It's
Foo is equal to whatever this function is returning.
Oh, okay, right. So what is the undefined component?
The for each, right? Because this array.for each, it doesn't return anything. So by default, in JavaScript, anything that doesn't return something explicitly returns undefined.
Okay. Explain that again, one more time. So that's the return 1, right?
Nope. So if I comment out this and just do that. So assuming console log num takes in a number and just logs it out for you, if I run console log num, it's going to console log out var1 for me. But what is this function returning?
In this case, just returning one.
It's not, right? Console logs and returns are very different. Console logs is only for the human eye to see. A computer basically skips over console log. So this function doesn't return anything. And so in JavaScript, when a function doesn't explicitly say I'm returning this value, it always returns back undefined for every function. And so that was why up here when I call this for each executes a function for you, but it doesn't return anything. And so therefore the function implicitly returns back undefined. Cool. So that's the first one, for each. There's gonna be five of these. So it's like it might be quite a bit, but as you use them and you get more and more familiar with them, you actually see that they're actually super handy for doing a lot of kind of more tedious commutation. And I'm sorry for the font. It always does this whenever I put it in full screen mode. It like just does weird things to the fonts. So going back to the example really quick right here. Oh look, we have a function that takes in 2 arguments, right? The first one is the value of the element. The second one is going to be the index of the element. And all it does is it says, hey, I'm going to start off with a 1, and then for every number, I'm just going to multiply the 1 by the value. So what is this? So what is this going to have? Like, what's num going to be by the end of this? And like not the number value itself, but what is num going to be by the end of this?
I mean, it's going to multiply all three, but it's only going to return 2 times 3, which is going to overwrite the other values as it goes, right? I mean, it's going to do, because it's only returning one number, it's going to do 1 times 2, get 2, and then it's going to get 2 times 3 and 6, and 6 is going to replace the 2.
Right. This is going to give you the product of all the numbers in the list, right? It's basically just writing one really long multiplication table for you. It's like 1 times 2 times 3. I have 8 numbers here. It'll be 1 times 2 times 3 times 4 times 5, etc., right? This is just the product of the list. And so if anyone ever says, hey, David, what do you get if you multiply all of these lists, all these numbers together, right? Like, let's say these were all percentages, right? Like, you know, like the house costs $100, right? Or, sorry, maybe like $100,000. And you know, like, the realtor gets 10%, right? You know, the owner gets, like, you get 10% of that, and then taxes go. Like if you ever try to nest down through a list, this basically allows you to go through and take the product of all the numbers together in the list. Obviously, product is something that's used a lot less, but a more common usage is sums, right? What I want to do if I want to add together up all the numbers in a list, and there's actually a function that we have specifically for summing up things in an array that we'll cover on next. So after array.forEach, the next one we have is filter, which I'm actually beginning to appreciate a lot more as I write more and more code, right? What filter does is, filter, once again, all of these do the same thing. They loop over the array, okay? Like for each, it also takes in a function. It takes in a callback function, okay? And like for each, the callback function it passes into it is 3 things: the value, the index, and the array. Okay, so everything's true for that so far. However, what filter does is filter is going to evaluate this function on every single element in the list or in the array. But what it's going to do is once it evaluates that, right, it's going to take that value, that whatever they get back from it, and it's going to convert it to a Boolean. It's going to be either true or false. And what that Boolean tells filter is say, hey, I'm creating a new list. Do I want this item in that new list? Okay, so if I have a list of, in this case, I have a list of numbers here. Okay, this is probably not a good example, right? But let's just say I have a list of like numbers here, right? And I only want to keep, or I want to remove all the numbers that are bigger than 5. Okay, I want to remove out all the numbers that are bigger than 5. In my function, when I take in a value, all I want to do is I want to return, right? Return if the value is greater than 5. If it is greater than, if it's less than 5. If it's less than 5, then I want to return true and keep the number in the new list. If it's greater than 5, it's going to return false and that tells filter say, hey, I don't want this item in my new list. So filter, as the name implies, go through your list and filters the criteria for you. And the callback that you give it, what that callback is doing is trying to compare it to something usually, is trying to return a Boolean to tell you, should I or should I not keep this item in the list. So an example of when I was using this recently was we basically had customers with a bunch of orders, right? And for us, we only wanted to measure the orders after a certain date. So if I have a list of someone who bought like 30 things, and I want to figure out, let's see how many items they bought after this date, filter was a great way for that, right? Because all I need to do is filter over these orders, and for each order to say, did this occur after this date or not? If it did, then I keep it, so true. If it didn't, then it's false, and then I exclude it, okay? Really important down here in line 7 and 8, right? So here we're running filtered, so a filtered array. So in this case, what we're doing is we're actually removing all the duplicates in this list, and the way it does that is by using the index of function, right? And it's saying, okay, if there's only one number in this array, then the index of that number should be equal to the index here. That kind of makes sense? Like if I have a number and if I only have a list of have one number and it's like 3, then the index of that 3 is going to be equal to the index of that number, right? If I have 2 numbers that are 3 in the array, one of them is going to have the same index as a value because index of reads from left to right, right? And then the second one's going to have a different index. And so that's all this one is tracking. It's trying to say that, okay, if I go through this array from left to right, and I'm looking for a given number, is the index of that number equal to the index of the number I'm currently looking at? And if they're not equal, then it must mean there's another instance of this number somewhere. Okay? So what this is doing is it's basically going through the entire list and taking out all the duplicates. And it's capturing that duplicate list in this variable called filtered array. When we look at this filtered array variable we print out, we actually get all the numbers, right, without any duplicates. But when we look at our original list, we'll see that nothing has changed. So one of the really key things to know about the filter function, right, is that filter returns back a new array. Okay, not a copy, not a subset. It returns an entirely new array variable. Right. So when Sean talked, I think last Thursday about pass by value versus pass by reference, right? It's super important for us to know in this case is, hey, I know this array I'm looking at right now, it's filtered, but is this the original array or is this a new array? And in this case, filter always returns back a new array. For each returns back undefined, filtered always returns back a new array without changing the original array. Okay. So when you write a filter, when you look at your callback in the filter function, no matter what logic you do elsewhere, the last line should always be a returns true or false, because that's what filter knows how to read. And if you give it anything else, it will try its best to coerce it into a true or false for you. Any questions on filter? Make sense?
Just, if you did want to do the less than 5 thing, you just change the INV to a 5 and the last part of the next line to less than 5.
I would just take line 4, remove all of this, and just do return val less than 5.
Right.
That would be it. Okay. Cool. So filter. It takes in a callback that returns back a Boolean that lets you know if you should keep it in or not. Yeah. And this basically down here just tells you that, hey, we can do this like I showed you earlier in the repo, right? We can either use a variable name here or we can pass in an anonymous function. It doesn't really matter as long as it gets back a function. Cool. Next one, .sort. .sort is kind of tricky. And so .sort, when you look at the original one, so first of all, like, what do you notice here in terms of what .sort is doing, right? It's not returning back a new array. In fact, what it's doing is actually is that it's actually mutating the original array. So that's one thing you always want to be really careful about is when you use .sort, is that it does impact the original array. Okay. what dot sort does is it actually the arguments. So it takes in a callback, but what it gives the callback is a little bit different. The first callback argument is basically what is the value of where we're currently at in this list. And then the second argument, as opposed to the index, is the next value, right? So how sorting really works is basically imagine if I have a list of 10 numbers and I have a window, like a pair of binoculars, that I can only look at 2 numbers at any given time, okay? And so what I'll do is I'll start at index 0, index 1, look at those 2 numbers, and I'm going to do a comparison of them, okay? And when I do a comparison of them, basically this is going to return a number, right? I need to get back a number. I think the way that what it does is, okay, so if the callback returns back a positive number, so if it returns back 1 or any number bigger than 1, that's gonna tell it that, hey, switch those 2 elements. Okay, so if I have so in this case, in my original array is 3, 2, 1, right? I have my binoculars. I start at at index 0. A is going to be 3, and B is going to be 2. And I say, okay, great. Return to me 3 minus 2, which is 1. It's a positive number, right? And so that positive number tells me that, hey, these 2 things should be switched. So after the first pass, what I'm actually at is, after the first pass, my array is going to look like 2, 3, 1. But I'm not done yet, right? Now my binocular, I shift 1 over, now I'm looking at indexes 1 and 2. And what's index 1 now? The 3, right? Because I just switched it. And then what's index 2? 1. So I return back 3 minus 1. Is that a positive number? Yeah. So that means those 2 are messed up as well. So I want to switch those. Okay? So now my index is going to look like 2, 1, 3. Right? And and now what sort does is it's going to start at the very beginning. How does it know it starts at the very beginning? Because it had to do at least one switch. The sorting function knows that your array is perfectly sorted if it goes through the entire list and doesn't have to switch any numbers. So when it goes through this list, as long as it does at least one switch, mentally it knows that it needs to go through it again just to make sure that the final list is correct. So for a sorting function, the really important thing is that its end goal is to say, can I go through this function from index 0 to the very end without having to do a single switch? Because if I can do that, then it means this list is perfectly sorted. But anytime I do at least one sort, I could have inadvertently moved something else out of place. So I need to do another search just to make sure, or another pass just to make sure. Okay, so sorting. So what the sorting does is it always evaluates wherever you give it, and it's going to try to get a number. Okay. For the most part, sorting functions, it might take more, but you should rarely ever need anything more than 2 arguments, which is the value of the index we're currently at, and then the value of the next number, or the next value, okay? The other thing about .sort that's, also any questions so far on .sort before I talk about some of the nuances? Yes?
Are you typically going to be returning A minus B when you're doing a sort?
Only if you want to sort a number from smallest to biggest.
Okay.
If you do it, well, there's, what if you want to, I forgot how it works. If you do B minus A, you're going to get biggest to smallest, right?
Right, because in that case, you're going to keep switching things around until the second number is the smallest over and over again.
Yeah, I mean, but in a practical sense, if the result is greater than 0, it's low to high. If it's less than 0, then it's high to low.
Yeah.
Right.
Does .sort make sense to everyone? When you use .sort, always remember it as the 2 main things to remember about .sort are that the callback is going to give you a number, and then if that number is bigger than 1, it's going to change the order of those 2 items. If it's less than 1, it's going to keep those two the same. The second thing about sort is that it mutates the original array, and then the last thing is that, remember, it goes through it over and over again until it successfully goes through it one time without having to change anything. Like that for the sorting function is the end game. So if I can go through it once without making any changes, then it means this list is perfectly sorted.
Yeah, it's called bubble sort, right?
Yes, yeah. So sorting is like one of those things in computer science where it's like people spend their whole careers trying to think about better sorting algorithms. And so what we're doing now is actually not very efficient, but for most computers and for most lists that we deal with, it's actually going to be fine. one caveat about dot sort that's like really dangerous, I really hate how they did this, is dot sort also works if you don't pass it a function. Okay? And what it does by default is it does that. It does a minus b, I think. Okay? The reason why that is really, really dangerous is because if you have a list of numbers, it will work. But if you have a list of strings masquerading as numbers, it won't, right? Because in JavaScript, 11 is smaller than 2, right? Because your first character is a 1, right? Like that's, in binary, it's smaller than a 2. So therefore, like when you try to sort something that's not pure numbers, you can call it dot sort on it, and JavaScript will do its best to try to convert everything to binary to compare it for you. But it's very, very dangerous because of the fact that it does a lot of type coercion on your behalf and you don't see it, and it doesn't throw an error to you. So I would almost say never ever call dot sort without having a function explicitly stating what you want, right? Because the other thing about dot sort is that like the way the computer think about comparisons is like super different than the way the humans think about it. I would actually personally, I would prefer if dot sort didn't work, if it made you specify a callback. But because the smallest to biggest is such a common sorting method, they kind of pass it as a default. But you should always have a dot sort function in there somewhere. Or sorry, you should always be passing in your own custom sorting function into the dot sort. Like never really rely on JavaScript to do it for you. Okay, any questions on dot sort? So we've done filter, for each, and sort. Yes.
So, and the first example on the left.
Yep.
Because you do have a function and it returns a minus b. What if you did have a string in that array? Would you get an error? Or?
No, it will sort it, but it will just look really bad. So let's try it. So let's say I have like a 1 and a David, right? And I say array dot sort. I don't need to capture it because it's gonna. Okay, well in this case it did its best. But let's just say if I had like a 1 here and a 2 here and then a 11 here, it sorts it according to the string values, to the Unicode value of the, or it's either binary or the something else, but basically converts it into like non-human readable language, and it compares it, right? And because theoretically speaking, when I look at the first digit, 1, 2, 1, obviously this one's smaller, so I'm gonna move this 1 over. And that's why when I do the default dot sort, it gives me back this order. So it doesn't throw an error, which is even worse. If there an error, I knew it, I messed up, I can figure that out. But this will just silently fail for me. It will give me back a list that could look very close to what I think it is, and I'll just do stuff with it, but not knowing that behind the scenes it's actually like breaking. So the only way for us to get around this is we pass in a function here, right? A comma b, and I can say, hey, no matter what it is, let's try converting to a number first, right? So let's do number a minus number b. I'll return this, and now I actually get back my correct sorting. Okay. Don't ever use sorting without don't ever use sorting without passing in your own like compare function, because you're just opening yourself to a lot of risks. That's not necessary. Okay, sorry, my voice is a little hoarse today. Any other questions on dot sort? Okay, 2 more. We're almost there.
The slide on the left was when you want to make duplicate copy of it.
Yeah, sorry. On the right.
What does slice without an argument do?
Slice without an argument just creates a whole new, an actual copy of the array, right? Slice just copies it. If you pass in an argument, it like takes a subset of that array and copies it for you. If you don't pass anything, it just says copy the entire thing. And so on the far right, we actually do need new array because array.slice returns back an array that's used. And I'll cover that a little bit more when we talk about chaining functions and what chaining means. Okay. If I have, for example, a list of objects that I want to sort by a certain key, then what I do is something very close to up. It's very close to up here, right? Is I need to specify which property I want to sort, right? So if I have, a bunch of people captured in an object, and I have their name and age, and I want to sort them from youngest to oldest, right? What I want to do is the compare function should be doing it on person A dot age compared with person B dot age. Okay, so objects are sortable. You just need to be very, very clear about which key you want to sort on. I don't know if sorting objects works without passing in a sort function, but like I said, you should really just always be passing in your own sort function. But yeah, so here, we're looking at a.keyname minus b.keyname, right? If you do a string or if you just pass in something by default, it might work, but it's not going to do what you want it to do. Okay, cool. So that's sorting. Two more. .map. .map is another function that people like a lot. So .map, it also returns back an entirely new array. So it doesn't change the original array. It keeps it the same. Sorry, it keeps the original array the same while making a new array. And the arguments in the callback are the same as what we saw for each and filter, which is the first value. The first argument is the value. Second argument is the index, and the third argument is the whole array. Okay, so map is really consistent there. What map does is, like filters, map is saying, look, I'm going to create a new array for you, all right? And this new array that I create for you, it's going to be the same length as the original array. You just tell me what you want to put in each slot, in each corresponding slot, right? So if I have a list of 3 things here, when I use .map, it's going to give me back an array of length 3, okay? And for the first item, it's going to say, okay, your first value is a 1. What do you want in this as the first value in this new array? And if I say, hey, can you give me an array where every number in here is incremented by 2, right? You just do return val plus 2. And it will say, okay, your first value is 1. So in the first index, in the first index of this new array, you want to have 3. And then for a second value, you want 4. And for the third value, you want 5. Okay, so .map returns back a new array. All it's doing is it's looking for your callback function to tell it what value it should be putting into the new array at the corresponding index. A lot of words. Does that make sense?
Yeah. If you wanted this to actually work like it is on there, you need to substitute 2s for in, right?
I would do what?
You need to substitute like the number 2 for IND.
Right. Right. So for .map, just remember you have a original array. Imagine .map just creates an empty array for you of the same length, and at each value of the original array, it asks you, great, what do you want me to put into the corresponding slot in this new array? Okay, so .map, you can have it return back anything. If you don't return anything, you're going to get back undefined in your array because that's what JavaScript does, right? So .map is really good for making a copy of an array, except you change something, a little bit of data consistently for everyone in that list, right? So let's just say, you were looking at a class and they all took a test and you want to curve it by like 30%, right? If you have everyone's scores and you say, I want to, add 30% to it, then that just means you go through this, you map this original array and you say, give me the value plus 30%, right? And in the new array, you're going to have everyone's score multiplied by 30%. That map, because it's an array coming from another array, the other thing and the reason why it's so important is because it actually preserves the order of the 2, right? So if I have a bunch of test scores for a bunch of students in a certain order, .map will preserve that order for me because once again, all these functions go from left to right sequentially. Okay, .map I would say is the one that's probably used. .map and .filter are probably the 2 most commonly used array methods in my experience. Cool. That a question, Rick, or?
Yeah, kind of.
Yeah.
After the function in line 26,
yeah,
the value and the index, I mean, that typically what we're going to be putting in is I'm confused why that's there.
Right, because remember, .map, like what it passes into the callback is the same thing that filter and for each passes, right? It passes into 3 arguments. The first argument is a value, second argument is the index, and the third argument is the whole array itself. And in this case, because we don't need the whole array, we can just say, hey, you can give me everything you want, but I'm just going to take the first 2 from you and do stuff with it.
But for like in your student curve example,
Yeah.
in that case, you would probably just ask for one argument, right?
Right.
You wouldn't need an index.
Exactly. Yeah. Like if you don't need the index, don't put the index in there. If anything, it makes your code easier to read. But the only thing is like because it passes it in a set order, if you do need the index, you need to pass in the value first, because the index will always be the second argument, the second parameter in your argument, or sorry, in your function. So if you need the array, you need to pass in all three, even if you never use the first two.
I have one other question.
Yeah.
When you gave that example about map, where you have one array that's all the student scores and another array which is their curve scores.
Right.
Are you saying that it would be valuable to have those two? Like, let's say that you wanted to, like, if you wanted to console log in one line their old score and their new score, you could just refer to. You could say you would know exactly where it was in both arrays. Like, if you wanted to connect one value to another, you could say this is student's old score, this is student's new score. Is that what you mean by?
Yep, totally. So here, if I just want to say, hey, let's just add like, add score plus, like 30%, right? And I console log AR, I now get the same. What did I do? Oh, cool. So now I have, and then if I console log out the original array here, right? And exactly, to your point, right? Like index 0 across both arrays is going to be the same student. Index 1 across both arrays is going to be the same student. And so if I want to say, I'll just do actually, no, I'll do a for each, I'll do arr.for each. And the function I'm going to pass into it is I'm going to need the index for this too, right? So I'll say, val and index. And what I'm going to say is scores for student. And then I'll add in the index. And then I'll add in this. I'll say old plus, what would this be? Oh, it's just val. Sorry, this is really contrived right now. I apologize. Give me like a second. And then comma new is gonna be foo index of int. So if I do this now for everyone, and I remove these two here, is now I say scores for student 0, and I can consistently say across both arrays what their old score is and what their new score is. Right, so this is why like map is really good from dealing with arrays, is because you're preserving the order of it, right? In a filter, you can't do that because you have no idea how many items are going to pass through your filter, right? You can start off with an array of 30 things and wind up with like 1 or 2, right? With a for each, you're not really creating a new array. And then with a sort, obviously you have the same number, but all the order is shifted. So .map actually does a really great job of preserving the order for you.
Yeah, the IND is because for each always returns 3 values. Or,
right. The arguments are value, index, entire array, in that order. Cool. Any other questions on maps? That a question or no? Okay. Cool. Last one, and this one is probably the trickiest one. It's .reduce. So what .reduce does is .reduce does a great job of answering the question of, hey, what would it look like? What would it look like if I want to aggregate all the values in this array somehow? Okay. And what does aggregate mean? Let's say I want to say, hey, what's the sum of every number in this list together? Like, how do I add up all the numbers together? So what reduce takes in is it takes in 3 arguments, or actually it might take in 4, but you should rarely ever need more than 3. Okay, and so the 3 arguments it takes are the previous value, the current value, and the index. Okay. Reduce starts at index 0. Okay, but when you're starting at index 0, what is a previous? The previous is actually this second argument here, down there. And so if you notice, all the other array methods we've talked about, right? They've taken in one argument, a callback function. I'm going to execute this function on every element of your list. Reduce takes in 2, and you should always, always, always have 2 arguments, okay? And what this second argument does is it basically tells you, hey, where am I starting? If I want to add up every number in this list, I want to start at 0. And I'll walk through a few examples of what it looks like when maybe adding up the numbers isn't what I want, okay? What array.reduce, what this return does is it basically generates the quote-unquote previous value for the next element in the array. Okay. So if I want to add up 1, 2, and 3, what looks like behind the scenes is this, okay? I'm going to start at index 0 at the first element. I'm going to say the current value for this is going to be 1, okay? And the previous value is going to be 0. So I'm going to return back 0 plus 1, which is just 1, okay? That 1 is being returned, right? So I'll leave here, okay? When I move on to the next element in the array, this 2 is the current, but what is the previous? It's a 1. It's whatever the previous, it's whatever the element before me returned, whatever the function for the element before me returned, right? So when I'm at 2, previous is 1, and 2 is current. So I return back 1 plus 2, which is 3, right? And then when I move on to the third element here for the 3, what is my previous? 3, right? Because when I was at 2, it returned back a 3, right? So that 3 is now my new previous, and my current is also a 3. So when I return back 3 plus 3, I get 6. And at the very end, once reduce says, hey, I'm at the end of my list, I'm done, it just returns back that value to you. And now you have a 6. Okay? So what reduce does is really well is it basically has this, what I like to call a container, right? You tell me what my initial container is, and I have this container that's just going to be passed on as I go through element to element. So in this case, my container is just the sum of all my preceding elements, right? Let's go. So let's get rid of all of this really quick. Prev, current. Okay, cool. And then here it's dot reduce. Cool. Okay. So if I want to add all these things up, I write dot reduce and I put number, and then here I just put back return prev plus. Okay. Oh. Cool. So this part, why is it 8.7? Oh, it's a 7. Ha. Okay. Cool. Oh. Also JavaScript, not good at math. Okay, I'll just. Come on. Cool. Okay. All right. Sorry about that. Okay. So here, like the reduces, right, is I start at 0, which is my initial container value is 0, right? I go to the first element, which is 0.9, and I return back, it's 0 plus 0.9, which makes a total of 0.9. Well, I move on to the next element, which is 1.8, I guess. I thought it was a comma, but whatever, which is 1.8. My previous becomes a 0.9 plus the 1.8, which is the 2.7, and now I've reached the end of my list. So that would end up getting returned here. Okay. However, this is like the part where like JavaScript gets a little bit like, I guess like this container usually is a number, but we can also make it something like an empty array, right? And what I can do is I can say is previous dot push cur. And when I run this, why do you not? Oh, come on. Okay, what did I do wrong here? Oh, because right. Okay, cool. Here, my initial container is actually an empty array, right? And as I go through this, the first thing I'm going to do is I'm going to push the current value into my empty array, and then return that array. So when I go to 0.8, I now have an array of just 0.9, and I can push in 0.8 and return that array, and then return it, and then do the same thing for the 1. So if I add a console log in here, I'll say console log array, or I'll say container thus far, and I'll put in the prev. When I run this, you'll see during the first iteration, I have an empty container, right? And then after I go through the first element, I now have a 0.9 in it. As I go through the second element, I have a 0.8 in it. And then finally, when I'm exit the array, the final array has 0.9, 0.8, and 1. Okay, so reduce basically just is really, really good at helping you have a container of things that you can then pass through to every single element in the array as you go through it. So it could be a sum, it could be an empty array in this case, it could be an object, it could be anything you want, as long as the one thing you really want to make sure you do with the reduce is you always want to make sure you return whatever you want the next instance of the previous value to be at the end of your callback.
Does this get used a lot?
Reduce gets used a lot for summing up things.
Yeah.
It gets used a lot for summing up things. It also gets used somewhat for iterating over objects, but not nearly as much as it does for summing. Like, all of this seems very convoluted right now, but as you go through and do some of the workshops, you'll begin to see why like these array functions do tend to make life a little bit easier, especially in terms of like writing cleaner code. Okay, so any questions on reduce? Yes.
So, why doesn't it exit? Because in our bar sum right now, it didn't return after each
Yeah.
after each iteration, right? Why doesn't it exit the function right away?
Well, so what does return do?
It gives you the result.
Right, but what does it exit? What like? Well, it helps you exit out of the nearest function scope,
Oh,
right? And notice how this is the nearest function scope right here. And so what all these methods are doing is it's calling this function over and over again. And so at each instance, it is exiting the nearest function. It just happens to be the function that's being called within. And then array basically, or in this case not reduce, captures the output and feeds it as an input for the next time it calls that function. So you are exiting the array each time, or the function each time.
Just really quickly, how would you use this on a regular object? Because objects don't have stack properties, so.
Right. So
How would you go through it? Really doesn't really make sense.
yeah. So like for example, if I say something like might think of a convoluted example for you. Okay, so let's just say like I have three numbers. I have four numbers: 1, 4, 6, and 10, right? And I want to make an object. Like my end goal is to be able to print out an object that looks like this. Okay, so on one object it's like less than 5. Okay, and it's gonna have an array of 1, 4, and then if I have something like greater than 5, I'm gonna have 6, 10. And so if I want to create this object, reduce is a really good way to create that, because all I can do is I can have my initial container as an empty object, and then I can say is okay. So if cur is less than 5, and then I have my else down here too, just so I know what I'm doing. Okay, and then here I can say, okay, if prev, and I'll say less than 5. Basically, this does this key already exists, right? If it exists, then I'm gonna say, okay, prev less than 5 dot push cur. Otherwise, prev dot less than 5 is equal to an array with cur in it. And then I'll copy this over for this thing as well, where in this case I have to say if greater, let's change this to greater. Great. And then I will, yep. So if I console log out this, did I have a empty this? My 5? Did I use? Cool. Like this helps me create like an object that does it. So like it's a really good way to create an object that classifies things for you, right? In this case, it was obviously doing something very simple, and maybe a filter would work better here. But it is a good way to kind of iterate over it and kind of create a new object from scratch, because you do have this like reference to this kind of master container. Yeah. Cool. Any other questions on reduce? Yes. Sorry, I can't hear you. Hey guys. My turn point now. Cool. Sorry, what was your question? Right. So in this case, a prev becomes the object actually. So if I just do my old console log here again, it says, "Hey, this is what prev is." You'll see that in the first iteration, prev is an empty object. Actually, I'll actually do this. So I really love console logs. I feel like they make this things a lot more readable. So I add these like bunch of asterisks here, so you can kind of see where the breaks are, right? So when I start off, my prev is an empty object. After I go through the first number, I've now added a 1 to it. After I go through the second number, I've added a 4 to it. And then after I go through the third number, I now added this greater than 5 with the 6 in it. And then after I go through the last number, I now have my final object.
What did you set up prev as an object?
Yeah, prev is an object.
Yeah, no,
You
okay, right. Okay.
Right. And the other thing that's really tricky about reduce is that they don't really have a rule for you of what you do and what order you do them in. So if I want to, like, I could very well easily start off with an object and then change it to something else later on, right? Like nothing's keeping me from returning this into a true, into an empty array, right? Except this is gonna throw an, okay, maybe it didn't throw an error, but like I can change container types halfway through, although it's really like very rarely advised that you do that. But yeah, just remember that like always return back whatever you want to be used as the next instance of previous. Cool. Any other questions on
Can you just scroll up to
Yep.
show where? So how did you give your object a name prev?
I gave it prev because here this is my initial prev value, and I called it prev here.
Okay.
Right. So if I called this, if I call like container, how do I? Is there like a find and replace? Does anyone know how to do a find and replace in REPL?
I find out what we got.
I mean, you can highlight multiple words.
Yeah,
But you have to
yeah.
manually
Oh, wait,
do
that's
it.
what we do something. What'd you do?
Oh, that okay. REPL.
You don't have to change for every single one. That might be tedious.
Well, I think there's a way to do it that's like super like fast though, and sounds like cool. Okay, maybe not. Maybe it doesn't let you do it. Okay, well this is not very useful. Okay, maybe Rebel doesn't let you do it. Just lets you highlight it. Unless if I highlight it, it does something else. Okay, whatever. But yeah, if I change every instance of prev to container, then it will do the same exact thing. In fact, if I change it only in one place and not the others, it's probably going to throw in an error to me telling me prev isn't defined. But yeah, this is where you define all the arguments are going to be used, or all the parameters are going to be used in the rest of your function.
So if you chose to use an array as your container, that would become a variable named container, and it would be an array.
I can call any of these things anything I want. I can literally call any of these things anything I want, right? Like the container is more of like description of what it traditionally does, but really it's just like, what do you want to be passed into the next iteration of this function, or next iteration for the next iteration of this function for the next element. That's the only thing you really want to figure out right here. Cool. Any other questions for reduce? All right, see none. Cool. So then the last thing, and then yeah, this is basically about using objects and reduces. You can read this kind of slide, but this basically just does what we just did. The last part is method chaining, right? So method chaining is something that is very poorly shown here. Method chaining basically says, hey, I can actually do several of these functions at once, right? Because map returns an array, right? Filter returns an array. So in those cases, reduce can return an array, right? So if I'm returning an array, it means I can actually call any of these methods on what gets returned right away. So here, like, if you notice what we're doing here is we have a filter here that returns an array that we then call .sort on right away, right? And the reason why that works is because we know array.filter returns back a new array, and then we're going to sort that array in place, and we're going to capture that into the new R variable. Similarly, if we go back to an earlier example here, the .slice, like that's also an idea of chaining, right? Because array.slice is going to give us a new array, and essentially after we get that new array, we can call .sort on it right away. So you can chain together as many of these things as you want. And in fact, for some of the problems tonight, we should try chaining together these things just to kind of get practice on how to do it. Just remember that these methods are available for all arrays, right? As long as you have an array, it can do these functions. So as long as you can make sure that each element, that the previous chain in your chain returns, or the previous link in your chain returns back an array, you can actually just keep calling array methods on it until at some point you don't get back an array anymore, in which case you have to stop. Okay, so method chaining is just a way to say, hey, like rather than saying, hey, here's an array, let's do a .map on it, and then let's do a .filter on it, and then let's do something else on it, and then let's do this on it. It's like, let's just write it in one long statement to say, I'm doing A, B, C, and D kind of sequentially. Once again, completely optional. You never have to chain anything if you don't want to. But in terms of just shorthand and making it look convenient and clean, sometimes chaining does make things a little bit easier. Yes?
On the other one, it had .slice. I mean, can you do .push? Can you chain off of that as well? Because it's...
Sure. So let's console log out some stuff, right? So let's just say I have like a var arr equals 1, 2, 3, right? It's our most typical example, right? And I console.log out arr. All right, that gives back 1, 2, 3. Okay. If I do arr.slice, that gives me back what? A copy of the array, right? So I can call something on this. But if I do an AR.push, what does that give me? Undefined. And the reason why is because this function, when I execute it, this adds an element to the original array, but the function returns undefined, right? .push mutates the original array, but remember, if it doesn't return anything, it by default returns undefined. And so what that tells us is that .slice returns a new array. You know how like .sort changes the array in place? If I try to do like an array.sort, oh right, how should I do this? Array.sort, why is it return? Oh, because this is, yeah, I think the problem is that it keeps the original array though.
Why would you expect something different?
I was expecting back undefined. Okay, so array.sort does return back the original array. So I make the 3, 2, like 4, 3, 2, and I console log out ARR. Right, so that changes the original array and the new, so it returns. Okay, so I guess .sort is a bad example because .sort does return back a reference to the newly sorted array. But if I try to do something on like dot reduce, for example, and I have a function that does a comma b, and then return true, and this is 0. Okay, cool. So if I try to console log out this, I'm gonna get back true, but I can't chain anything off of this because this function gives back a true. It's like basically what you want to do is you want to console log out, like for everything that you want to potentially chain on, just console log it out, right? So if I do array.push 4, that function itself gives me back an undefined, right? But if I console log out array afterwards, you'll see that I added 2, 3, 4, right? No, why is that not the case? Well, there should be 2 4s in, right? It's not deduplicating this. This is fun.
Is 4 need to be brackets or should it be in?
I don't think it's a brackets. What? It mutates the original array. Well, so at no point am I removing anything though. That's the rub. Huh, this is fun. Let's try to figure this out as a group. Why is this not giving what I wanted to give? Oops. 2, 3, 4. Cat is undefined. Right, because array.push doesn't return anything. Why does a...
4 being parentheses instead of brackets?
Oh, sorry, that's what. Yes, that's absolutely correct. That's exactly why what's happening. You're right. Okay, cool. That's what it was. Okay, good catch. Okay, cool. So array.push, what it does is it mutates the original array kind of in place, but it returns back undefined, right? Much like for each does stuff to it, it does some things, but the function itself returns back undefined. And so that's why you can't chain off of .push because .push returns undefined. But you can chain off of .map or .filter because you're returning new arrays off of those. Yeah, so if you just console log out whatever you want to chain, and if you look at the output and if it looks like an array, then that means you can chain off it. If it doesn't, then it means you can't. I actually didn't know that .sort returned a reference to the original array. I always thought it just kind of did it in place, but cool. That's fun. All right, cool. So any questions on the array methods from today? Cool. All right. Let's take a break, and I'll psych out pairs, and we get started. And then, depending on how we are or what kind of progress we're making, we can then do a group review. May or may not do a group review at the end of class.